Welcome again to Wickerson Studios. I am beginning a series of computational design for people interested in Grasshopper for Rhino 3D, and I'm doing it in honor of Hannah Lee Sun, which was a student from the fiber department and at the Art Institute, and she really has gotten it. She's graduated, she's moving on, she's looking into architectural schools and dealing in computational arts. You can see the effects of taking digital elective on her work and seeing how it transformed from fiber and maintained fiber, but became extremely, within a very short period of time, became very dependent on the design that was going into her works. And she started with simple Tinker code, and in a matter of a couple of months, started to understand Rhino and understand the parametric control and the importance of going into Grasshopper. So I'm just throwing this out there because I'm very pleased with her work and where she's going, and she kind of gets it, and she pushes me to go farther as an instructor and maybe get a heads up on more architectural study into Revit and thinking of Rhino Inside and thinking of the generative processes of Dynamo and certainly what Rhino Inside can do with Grasshopper. So I'm going to slowly creep there, but I'm still very much producing these videos for people like her that still need to get into Grasshopper and understand things. Possibly this series will culminate not only in refreshing and understanding the basic tools that are available to you through params and align curves, surfaces, meshes, intersections, transformations, but really starting the focus for people like Hannah to realize the importance of the maths, understanding your sets, and understanding your vectors and how they drive things. I'm not one to come at thinking of a final object, so I'm going to use the quad sphere as my example again. That every time I see a quad sphere, I get so excited about it, as most people know, and I'm just going to select and become this wonderful blue. But you can see really what that is, and I'm always into dissecting things before I start. So if I really want to gather some things from this incredible item, which is kind of an inflatable cube, and I'm just going to ramble here and riff off of some ideas. By now, you may actually notice in a lot of programs the Bifocals plugin is one of the first plugins brought in, and you have to go to Rhino and download, have access to your computer definitely, and you want to go into the special folders and deal with your I don't know if it's my libraries actually. User objects, maybe that was it. No, it's been so long since I brought in plugins. I have to think for a second. It's probably the component folder, going through and seeing all the things I brought in, and you'll see right off the bat, if I was to go alphabetical, you'll see there is, at least I believe there was, Bifocals as a plugin. It's one of the first ones you want to bring in. You want to make sure it's in that libraries folder, even though my face is sitting on top of here. I think I just moved it out of the way. It's hard for me to see. It's disappeared on me. But basically, Bifocals is a plugin that's very nice that allows you to work within your displays no matter how you like it. If you like to do icons, I really recommend doing that. If you've gotten very good in understanding drawing full names and you understand that these are brefs and these are faces and edges and vertices, I think I'm still at the stage of teaching and wanting people to see those full names and definitely the fancy wires. But you'll see what the Bifocals did. I think you can double click on it to activate it. I think. I can't remember. Let's disable it. No, if I take it out of the screen, you'll see all those names disappear. The only other way to kind of do this is to go in and group and then go into this section and then name each one of your tools. So you can see in here it's called Quad Sphere, but then you'd have to copy that, go to the group section, paste it in here, and then you'd see the Quad Sphere. And that just seems like a lot of work. So as I ungroup it, it disappears. The Bifocals is a great tool of popping in wherever you want to activate it, and everything becomes activated. When you do that, you can really deal in icons and start seeing things. But once again, I'm about data. I'm about numbers. I really want to get down to the point that whether I take this in the foldergram or take this AR, or if I take it into Unity, or do things with this in other programs, I think I am dealing in very basic computer types of integers, what are referred to as floats or decimals or doubles, and booleans of true false. And what I've constantly said is you've got to get in the habit of knowing these two, the panel tool and the param viewer. So if I was to throw in my faces, I've got 6 untrimmed faces counting at 0, and if I was to look at that in the param viewer, there would be one branch with 6 items. Edges, they'll be a little different. I'll have a series. Now you're not seeing the total amount, but if I went down, you see there's 12. And sometimes you don't want to get to that. And then go down here and you'll see that you have 12, one branch with 12 items. And then the vertices, you've got all these lovely vertices. You want to stretch it out, and it's X, Y, Z, and you'll see you have 8 vertices making up that quad sphere. And those are data that you can actually start to do things with. And this is how I dissect things and don't think of what I want to make, but how I can get there. And that's how I think I'm moving a little more into computational arts. I'm just going to keep moving these along this frame as I go and say, well, what could I do to this to make it more exciting? Well, there are points here in the vertices, and you've got 7 items. So immediately I want to go into sets, and I probably will focus on the maths, the sets, and the vectors for a while and see what comes about. What's nice is looking over here, I think that's kind of fun. I can grab the populate geometry and just grab that geometry itself. And it defaults, like I said before, go in and extract the parameter, and if you don't know what it is, go back to your param, be in the habit of grabbing this. There's a reason why it's yellow and it stands out here. See what you have, and you see you have a 100 count. Now that seems a little outrageous, so I'll show you a little technique of double clicking and typing in an integer 2, which will run from 0 to 10, and now you can populate. And as long as I click this, you'll see how many I'm doing. I'm populating all these points. And this is how you kind of grab data out of an item. So what I have here is a series of points. Let's say 6. I started with the 7. I can get rid of that now. And I have a bunch of vertices over here as a list item. I have other ones here. And when you start playing this way, you might want to separate your data. Take your param viewer and your panel tool and see what you have over here and see when things start to line up nicely. Well, right here, I did know I had 6 items. I had 8 items here and 6 items here. Well, it would be nice to think, if I hard-coded this, if you double-click and hit quotes and the digit 8, it's going to set you with a wonderful value. And because you're not dealing with multi-line data, that's something you're going to get into as well, a sense of wanting to turn that into multi-line data, which chases it on a branch and shows it. But right now it's not important. I can leave multi-line data off. I can put that in there. And if I'm so happy to stay with 8, I don't want people messing with that, I'm going to leave it there to indicate, but this is a good example of why you would want to internalize. And I think of that as actually making a constant, making something that's not changeable. Now, of course it is if you right-clicked here and you typed in the expression to count. If you typed in here and saw what the values were, you could clear them again, but right now you're actually set if you hover over that to 8. So it's hard-coded there, and it came from this number here, and I'm not going to change it. But I will leave this one, and what I like to do is just, whenever I have something that I have to be cautious over, I will group it. And it's just a little technique that I do, and I would recommend it for other people. Not that it's any standard, but now it's in yellow, and it's kind of cautionary. What does that mean? What's nice here is a seed is a script that's written within a random kind of function that if I seed, I can have these points, but every time I change those, they're going to move around and be 8 different points on the surface of that. Because I'm populating the geometry, I'm actually not, making it populate 3D. Now, if I did a populate 3D, that would be a totally different animal. I would have a region right here, and you'll understand right now, if I try and grab a quad sphere and treat it like a region, it throws it in like a box structure and throws it inside and in the middle and out. And you're not really dealing with a quad because that's kind of, I guess, you think of it as a trimmed surface. So I'm not going to use that one. I'm going to use the populate geometry. And that, of course, is dancing around wherever it wants on the surface of that. What's nice about that is I have 8, and the seed can be set again. If you like what you have here, set at 0. You can always remember that. And you can grab another panel of sorts. I'll just grab this whole thing and hit copy. It's cautionary. And I'm going to go into this panel, and I'm going to type, well, I like 12, and I liked 14, and I like 56, and I like 87. And those are the ones that I really liked as a seed. Now, what's interesting with that is if I grab that, it's going to read those as the settings at these numbers, but it's going to read them as a, not quite as a list until I hit multi-line data. Now it will actually populate 8 points at where that counter was at 12, 14, 56, and 86. And you've got a pretty cool thing that just moved into a tree of data. You have, if we take a look at what's just happened there, we have 4 branches with 8 items on each, as opposed to 1 branch with 8 items on each. And you can see again with the points here, because you're dealing in some pretty big numbers, you've got a new tree of data each time you go. And if this is not making sense to you, you really have to slow down in this computational series and realize that it's all important about controlling this data, because I've just made something very complicated from a quad sphere. And you'll notice the dashed lines move from a single item to a list of lists. And now what happens is, what happens to the geometry if I treated a single list? Let's just do this and take the seed count from a single list, which you could do hard-coded from the 8, or you could have it seeded at 37 and be able to return to those different patterns. And choosing that 12, 14, 56, and 86 were good. But what I want to do is just leave it as that single set of 8 points coming out to these 8 points. And what I could do is grab something quite simple. Now, you could complicate things tremendously for yourself by writing in a C script, opening it up, and this is where it gets a little intimidating, and writing your simple code to join 2 points into a line, which actually isn't that difficult if you know a bit about C, or if you choose to do this in the Python script. So you can go into these tools and write your own script as you go to make it work. Now, it's been a while since I did GHPYTHON, and I've been doing a lot of C lately, so I'm not going to actually bother with those two, but I'm going to throw those into a group and say, wouldn't they be interesting? I'm just going to center them up and space them, and I'll space this one down a little bit so you can see that's a GH script. I'm going to put it into a yellow and say there's an opportunity for something there. See, I really am just kind of thinking as I'm going. Now, I'm not going to do that. I'm not going to do what I just said. What I'm going to do is just grab basic tool, which I know is provided under curves. It's a line. And if I take all those vertices from the start points and all those from the end points, I'm going to get some pretty cool lines, and there they are. And you're like, well, what does that mean? Well, that's a pretty interesting line system that's there. But what I want you to notice, and if lines aren't enticing to you enough to get excited about, grab your data, slide it on along. You can see all your data by clicking here and see everything you've generated to date, from those initial quad sphere to the breadth and surfaces and edges to those lines that are generated in those points. Or you could leave it on to just see what you're clicking. What I did want you to do is, I have a couple of techniques, and I'm just going to show this as one that I really get excited about, and it's a little treat. But if I go in here and take a pipe tool and just throw that through a pipe at a certain radii, I'm probably going to want to downsize that radii as 1.00 and just pop that in, so when I bring that in, I can make that real small so I see those lines as pipes. And what's nice here is hard-coded. You can click on here and just go to none, cap at flat. But remember, these are just numbers. This is called enumeration. You've actually decided that 0 equals none, 1 equals flat, and 2 equals round. So you can go in here and cap them this way. Or you can override it by doing the quotation 2, which is enumerated at round caps, and you have it there. So you've overridden it. Or you can write in double click, and if you hit 0 dot dot 2, that's going to give you integers from 0, 1, and 2 snapping as integers, so you can actually decide in a slider form of what you want to do. And you can start tying this into other data that you have, and seeing what comes up. What would be nice is to have these lines maybe divided by a modular function, see the remainder. As long as you're dealing in mod 3, 0, 1, or 2, then you would have it deciding parametrically from the numbers you choose. Now, if that's not making too much sense, don't worry about it. I'm just rambling on mathematically to myself. But this is the item, and I think I'm going to pop it into the 2 because I like it. I'll just leave this one hard-coded here. And once again, I'm going to take that radius, which is parametric and changeable, and I'm going to take this function here and just say, here's 2 things to play with, and grab those as another group. And this might be complicating things a little too much, but put it into I have so much trouble with this. Put it into the yellow again, and you know you can play around with those and kind of caution what's happening. But what I wanted to show was what happens when I start to do multiple lists. What happens when I take 4 of these different systems and want them all as one? Well, that's going to make for a totally different animal. And there we go. You found something within a quad sphere with very simple programming, thinking of computation, taking your single items, moving them in the list, and moving them in the tree data, and ending up with this. Now, that isn't interesting enough. I'm going to do one thing that I get very excited about, and my techniques are so simple, which is why I'm showing these as a kind of introduction to computational arts in Grasshopper. It's not the basics of Grasshopper. You need to have the basics of that to do this. But there's another tool in here that I love so much. Do what I just said I was going to do. I'm going to go into my pipe tool, And I'm actually going to set my edges to 1 instead of 2, because take those round edges. This sometimes helps because I'm thinking of actually manufacturing, going back into the real world. So I have to go back into the Rhino window to enter that, because computationally I kind of put that in the realm of forms, then Grasshopper's the programming, and Rhino's like, how do we get this out into the real world? So I'm going to group these all together, and there they are. I'm going to leave my Grasshopper window, so that's all gone and split. I'll open up my Rhino window a little bigger and show you exactly what I'm going to do, and I will take my little zoom extends to my frame so I can spin that around. And there's a tool I like in here. You'll see some awkward things here, and this is where you get a little fancy and you just have to get used to it. I am going to, first of all, Boolean, see if I can pull a Boolean union out of this thing. Now, because there's no round edges, there's no sign or variable pipe, which is what I was going to do, you'll see it created those meshes. And the other tool I like to do is, I don't like to deal in solid stock, I like to deal in pipe when I'm actually fabricating or welding up the form. So I'll put shell, and I've set the thickness to already 0.05 because I know the scale of this form. I'm just going to select edit a couple of surfaces to open up, and actually I don't even think I'll select that one. I think I'll stay simple and grab the ones that I can actually see flat, and we'll keep spinning. We'll grab this one and maybe that one. And now I should be able to hit enter, and the shell is such a wonderful tool that if I was dealing in pipe that was 0.5 millimeters thick, even though this does look kind of strange, it's processing. There's going to be a little problems with this because I may end up with some surfaces that didn't form a solid, and I'll show you another technique for just cleaning that up. And now I'm getting a little bit back into Rhino and fixing my computational errors because everything looks perfect in the Grasshopper window, but when it comes down to it, you're going to have to make some things. I might hit pause while I'm waiting, but let's just give it a couple more seconds. Surface shelling a process, and it says the shell did not create a solid, but you'll notice that most of these things really did work. Got some very cool pipes that have tried to make this whole thing hollow. Now there are some surfaces that are floating around here, so what I would do is use my selection tool or just do select surface, select that, grab the ones, get rid of those, and then be pretty happy with the forms that I've left, which are these solid kind of objects of going in. I didn't hollow those two out, I only made those two hollow and those two, and I thought I had another one here. So that's an interesting little shape made of pipe. If you actually want to explore that, you'll actually find out very quickly, going in and taking one side off, that was hollow. But keep in mind that I didn't choose to make that hollow, so it didn't cap it afterwards. So you're probably, if you didn't do it on the initial stage, you're not going to want to do it now. But there's a way they end up with a little object. I always like my Rhino in the end to go back into all views. I like to zoom extends all. This one I flipped over totally crazy. I will zoom in on that structure. I like to see this one in a rendered mode. And I will do just a quick rendering for you, even though I know I'm moving away from things computationally. In the rendered window, I like to have a gradient on the bottom. I like to color it probably a different color from what I'm playing with. I do like a dark blue. I will say OK to that, and running down, I may have a ground plane. I will take off any of my skylights because I don't like those. It's not bad if I'm not taking it to a ray trace or a long render. We could leave that on, or we could do sun. I think what we'll end up doing is skylight. This one I always like the view within technical. It may take a few minutes to run a technical, but it didn't. And this one I like in pen because I know I'd like to do drawings like that. And this one I'll do not in pen. I'll take that one over to artistic. This is just the nature of what I like to do for renderings and show things. I'm not taking anything to 2D. What I also like are my materials. I'll add a little material. We'll grab paint. We'll choose a color. And I'll choose something complementary, or orange, or yellow, or a deep dark yellow, or maybe a bright yellow. Let's just grab that and let's apply that to this object. And what's nice at that stage is clicking out of it, which should allow me to click out of it. Select objects and enter when done. I might throw something metallic on there, but you can also do your analysis tools at this point, which are always kind of sweet. Surface analysis, environmental map, and there we go. We've got something metallic underneath that that wonderful yellow finish that's on there. So we've made an object. We've actually done it. Let's just take a little breather and go back to where we were. We've made that object and all of its sketches and models. We may end up fabricating it. It's a pretty interesting object. I like it. From a quad sphere, which was our initial information. I debrepped it to get a bunch of data, which were just points. And I actually would have gone in farther and I will do this in the future for computational, I will take those points and I will dissect them into their attributes. So I literally will take those vertices and say, okay, what are the components, which are literally numbers? What are the x components? What are the y? What are the z? And I will do things with maybe some more programming over here to get a hold of that before I bring it back into points and manipulate it even farther. Now, because I'm not doing that, and all I did was really produce a cloud of points within here by a multiple list of items. I drew a line between them and I threw a pipe on them. I didn't get too crazy with variable pipes. We've ended up with something very interesting. We've thought about it, and the whole time we've done it, I have kept you focused on what are panels, what are the branches, what are the lists of lists, which you'll get later into your coding and scripting as data trees have to be generated through lists being generated through single items. Now, the whole thing is, of course, parametric to the radius, but that's where most people think about this from the outset. If I like a script that I've worked on, which I do, I will take it and I will pop it into a group and make it a delicious, fantastic blue, a little faded. We'll save that. We'll slide that one down here and say there's a nice little shape, and I'll be sending that to my GitHub for those that are interested in computational design in Grasshopper for beginners. Thanks very much for watching, and I'll talk to you another time.